All right, so let's start with the webinar for the session for today. Thank you once again, everyone, for joining in, taking your time on a Sunday and joining us on this special session. So this is a new series as a part of our original series, Deep Dive with IIQF experts. So within that, we have brought out a new series on masterclass on BFSI Machine Learning Skill Navigator, to explore the skills that are required to make a successful career in machine learning, particularly as applied to finance. And we'll be having a series of sessions as a part of this series as well. First session for today, as you all know, is on desired machine learning career and interview skills. And to guide us on this, who better than Sanjay? So Sanjay Bhatia will be the speaker for the day. And Sanjay has, to briefly introduce Sanjay, he has done his MBA and MSc Machine Learning and Artificial Intelligence from Liverpool John Moores University and postgraduate diploma in Machine Learning and Artificial Intelligence from IIIT Bangalore. Is currently working as a director with UBS Risk Modeling and Analytics, Model Risk Management, Control, and the Chief Risk Office function. Sanjay is a risk management and analytics professional with more than 15 years of mainstay experience in risk models and methodology space encompassing Basel, Advanced AIRB, IFRS 9, IMM, and SACCR exposure, XPA, FRTB, OTC derivative pricing, and other advanced modeling topics. Previously, he has worked with various foreign banks, Barclays, RBS, Citi, Credit Suisse, etc. in risk consulting. He is also very passionate about imparting practical model understanding and insights and has been a professional trainer for corporate and investment banks. He has been one of our lead trainers as well for now almost a long time, 4-5 years. So his area of interest are credit and counterparty credit risk, market risk, stress testing, stochastic modeling, quantitative finance, and machine learning, of course, since he has a specialized in that. So before I hand over the session to Sanjay, just a brief I mean, intro and how we would go about in the session. So today's session would be totaling about 1 hour 45 minutes to 2 hours. So essentially, we're in like about a little more about 1.5 hours. Sanjay will be guiding us on the topic of the day. We will be discussing that, and then post that we would be having the Q&A. So I mean, as I have requested earlier, please make the session interactive. Unfortunately, since the audience is like quite a large set, so we'll not be able to allow you all to speak up. But nonetheless, please feel free to type in your questions, queries, any specific thing that you would like to hear from us in the chat window, and we would take them up to the best of our capacity as many questions as possible within the time frame. Right. So with that, I will hand over the session to Sanjay. Sanjay, I'm making you the presenter.
Are you able to see my screen?
Yes, yes, we are able to see your screen.
Okay, in the meanwhile, let me maybe thank everyone who took time to join these sessions, and it goes a long way in the commitment to becoming a very nuanced professional in this niche field, niche but yet pervasive field, which is maybe from a BFSI standpoint, the machine learning, AI, data science has become all pervasive throughout the years, and most recently,
Absolutely.
maybe right, with the ascent of the computing power and the data we have, the big data technologies we have, it is becoming even more pervasive. So let me maybe first of all set the tone for what we are going to cover today, and how it would lead to this series, maybe which we have started on the career journey and the core competency and skills required for somebody to be a machine learning expert in the financial engineering, quant finance, risk management domain. So basically, this is first of the session from the series, which we are going to have subsequently have multiple sessions on this series. And this session will you know provide the some of the groundwork for how to understand what skills, what core competencies, what requirements, job description requirements you see through and you come across when you talk about mostly specifically the BFSI jobs, financial careers. And when they are aligned to the machine learning role family, or data science role family, or artificial intelligence role family, what do we mean by that? Because there are a lot of maybe buzz around, there are a lot of uh, you know and cliches being thrown up, right, to describe those skills. And it varies from job description to job description, from role to role, from employer to employer, right, from fintech versus the traditional banks. The terminologies are a lot more confusing, and the parlance need to be a bit standardized to understand what they actually mean when somebody put their mind when somebody wrap their head across around maybe how should I develop those skills, and what are the actual desired core competencies required for machine learning or data science in financial uh, risk domain, right? So maybe let me maybe get started with an overview of those skills, which I call the six P's in a marketing flip way, the six P's of machine learning and data science, specifically in the context of BFSI industry and financial use case application, but broadly in every industry, be it biotechnology, pharmaceuticals, aerospace, e-commerce, startups. In every industry, this is same, but specifically when we go drill down into each of these skills to understand what they actually mean for us, and what kind of core competencies I have to build to be called a skilled proficient professional on each of these aspects. We will specifically talk about the BFSI context there, right? But in general, these skill family and the core competencies which are highlighted uh, are pertinent to the overarching structure of the machine learning uh, you know driven jobs and machine learning driven role families. So broadly, these six P's, what we should maybe understand is for ourselves. First is the programming skills. Now, people generally have multiple thoughts and mixed up thoughts about programming skills. What they typically understand and misconstrue the programming skills is learning a particular language, like maybe Python, Perl, Julia, or maybe any language. So this is maybe sometimes when you would be assessed uh, for a machine learning job, this would be not be enough, right? So the calling for machine learning job requires somebody to be a full stack application designer, who knows the front to back tech stack of how the machine learning algorithm has been designed, how it is being developed, and how it is being deployed in production systems. So that's maybe what I want to in general talk, specifically talk about, that here the programming skills are not just about learning the Python scripts and learning few libraries in Python, right? Obviously that would be the core of it, but in and around the entire ecosystem of what kind of technologies and tool stacks will work in order to maybe design the model, develop the model and deploy the model in the production system. And the challenge, some of the related topics with respect to that is, you now hear a lot of big data technologies, Scala, Spark, Hive, who, so you, on the front side, you got to do the data extraction and data sourcing, using these big data technologies. Then you have to build a ML pipeline, which we are going to discuss in a while, right? How to build a machine learning pipeline. And then you are going to also decide upon how to deploy it on a cloud infrastructure, right? So these are some of the other uh, interventions, front to back uh, technological interventions, which have made the ML, holistic ML pipeline, right, a bit of more technology driven rather than just knowing the language or script, which is the middleware of the this front to back architecture, right? So we have to know the frontware, we have to know the middleware, we have to know the backware. What is the data technologies behind the algo? What are the visualization and reporting layer, how data is being visualized and reported, which technologies and which front end dashboard are used for dashboard driven technologies are used for developing such front end applications, and how basically in between the main ML algorithm pipeline is built, right? So that's about programming skills. We can call it programming skills because how it is being said in most of the JDs job description, it is called programming skills. But to be a successful mid career professional, your proficiency would require you to know the back end, front end, and middle end, both all these three front to back aspects of how the algo is designed and developed and deployed, right? The next skills is very important, and generally people sometimes uh, say that machine learning is agnostic. Yes, machine learning and data science skills are agnostic. You can switch industries, like if learned in a particular industry, and finance, BFSI is one of the complex domains per se, right? If learned for one particular domain, you could be hired in some other domains, because most of the other domains, e-commerce and other domains, doesn't require that much domain understanding, because the use cases are quite driven by the application of machine learning techniques to simple use cases, like where some of the marketing use cases, marketing analytics use cases, and some of the other profitability and loss forecasting use cases. But it's not that straightforward in the BFSI risk and financial domain. So a machine learning expert need to be very versed with the financial use cases, the risk use cases, the quants use cases, the financial engineering use cases, the computational finance use cases, which generally are, for an example, the pricing risk, how you manage the pricing risk, or how you do a forecasting or prediction of the pricing risk, the position risk, and the portfolio risk. So broadly speaking, we will go deep dive into this. What are the use cases available? And specifically, in last 5 years, I accumulated most of the from the recent research papers, what are the upcoming and highly interest use cases in the BFSI industry, which have been tried out using the ML algorithms, right? So the problem domain understanding is very much required, and that's where you differentiate yourself from a pure techie guy who just know most of the tech bits, right? And who is a full stack developer, right? So a machine learning job role family could be a more leaning towards a tech stack developer who knows more of the tech stack, could be leaning more towards a domain expert. But a domain expert still need to have a good decent understanding of the front to back tech stack, or maybe the machine learning operationalization, what we call ML ops, right? So we are not maybe discounting anywhere. Similarly, on a tech stack developer should know the domain, right? But there would be some role families would be leaning more towards tech. There would be some other would which would be leaning more towards domain or functional understand functional applications of those particular ML models. But that is the must to have thing skill which is desired and required, as you pursue your career in any of the fintech companies or any of the evolving you know uh, companies which is driven by the fintech algorithms, right? The next is what I call generally, there are different names to it and it links it to the data. In conventionally, people generally talk about how the data is manipulated, the data manipulation is done, how the data exploration is done, exploratory data analysis, how the different data science concepts have been used to draw inference from the data, right? How we have used those statistical inferences to 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 see maybe that we should not assume any underlying distribution for the data, rather we should do it in a assumption free way. So the ML algorithms are specifically about developing the model based on the data rather than making some assumption about the underlying data distribution. But while doing so, you got to understand some of the distributional properties, how the data is distributed, and you got to draw some of the useful insights, deep insights from the data. And that is the role of data science. Why you would be doing that? Because the machine learning algorithm, before deciding upon the technique, which technique to apply for a particular problem solving, you got to understand uh, what is the pattern, right? What is the noise in my data? So once you get to that, then you could be able to make an informed decision that okay, this kind of pattern could be better, you know uh, you know better built into a model, right? Using this technique, this kind of ML technique, then your ML catalog of technique could be used to pick up a particular technique which will be better at uh, predicting that particular pattern. So but all of it is, I would call, pattern detection skills. uh, Whether you apply some data science, you apply some statistical inference, you do some data mining, you do some data manipulation, all these, whatever you are doing, the end objective is that you want to segregate the noise in the data from the pattern, and you want to harness that pattern to build a model. So that is called the pattern detection skills, right? Which we will cover maybe, which are named differently, but eventually what I'm telling you is that the end purpose is this: in order to build a core competency, you should be self evaluating your proficiency, whether you are able to detect the correct pattern in the data or not, and segregate that pattern from all the noise. And the financial data is characterized, one of the unique characteristics of the financial data or risk data, or maybe the banking data, is that it is characterized with very high noise and very little patterns. So it is even more difficult to deal with the financial data sets, uh, where the pattern is very there are only few patterns which could give a clear indication of how to build a relationship for predicting your variable of interest, right? So that is the pattern detection skills out here. Then obviously you would go and maybe you know you would require a good hands-on understanding of the predictive analytics skills, which would require you to know how the stochastic and probabilistic modeling happens for different use cases in risk, treasury, finance, compliance, trading, all these applications, right? So what different models are built, how they are formulated, how they are specified, right? So this area basically specifically require you to understand the predictive analytics part of the model building, right? How to formulate your problem, how to maybe specify the basic design of the model, right? Whether it's a regression problem, whether it's a classification problem, whether it's a clustering problem, whether it's an association problem, what kind of problem it is, whether it's a time series problem, right? And what kind of different methodologies and models are used to address the problem at hand. So this is predictive analytics skills, which obviously is also the focus, because it's not just about uh, you know uh, teaching somebody a machine learning technique. They should be first taught, as per us, they should be first taught what was the conventional way of doing, how the conventional model has been used, what kind of conventional modeling or methodology techniques have been used for this kind of a problem. Then it would be better that to call out the flaws and some of the deficiencies and shortcomings of those conventional methods like regression, the multivariate regression or clustering, or maybe some of the classification, association, or these, and time series. And then we need to tell them that this is the alternative, this is the new benchmarking or challenger way of doing this. These are the ML technologies, we could use that instead of the conventional methods, to design it in a new form, which is purely data driven rather than the assumption driven model which we have built in the conventional way. So that's the again one of the very core skills, along with pattern detection and predictive analytics. So these could be seen together, maybe, right? Because all you are doing is applying statistics, probabilities, probability theory, statistics, and mathematics to get to the point, what kind of data you are dealing with, what is the patterns in those particular data, and what kind of maybe predictive analytics models and methodologies you should apply to to build a model out of it, meaningful model out of it. The next one is purely ML driven, right? Because which we call performance optimization, right? So once a model is designed and sort of a model is developed, right, it doesn't directly go into the production. You cannot simply implement it unless you uh, do certain experiments, certain trials and error with machine learning models, because there are a lot of hyperparameters of those models, and they have a huge number of hyperparameters, you know relative to a traditional model. So those hyperparameters, some of those additional parameters of the model, which are specifically the case for machine learning models, need to be trained on the real time. Need to we need you need to decide what are the optimal set of fine tuning parameters for the model, right? And you do certain experiments, certain trial and error, certain simulations, to get to understand at what level my machine learning model will have a fastest convergence rate, at what level I can do some hyperparameter tuning, in order to utilize data better, in order to maybe do the validation of the model on the real time, in order to do the calibration of the model on real time, how to design the model. Some of the design elements of that particular each of the machine learning technique would go here. So once you build a model, you need to do a lot more to make its performance fine tuned to the real productionized use cases. Because to be very clear, the expectation for machine learning models or machine learning expert is that they are going to produce a real time analytics, which was not that the case with a traditional statistical model, where the real time analytics was not a promise. Here the promise is that you're gonna produce a real time analytics. In order to produce a real time analytics, you got to build the model so that it will uh, you know just take a very little time, and you know with the reasonable accuracy, it will be able to produce the output very faster than a relative to a statistical model, right? So that's why performance optimization is key for ML models, which was not the case in the conventional or traditional model build out pipeline, which is an essential skill, core competency required, that you should understand. Somebody should have skill to understand what are the different optimization uh, algorithms or optimization techniques under the ML umbrella. So that's where it is required. And these different shaded skills are skills, some of the hardcore skills, but there's a creative side to uh, ML as well, where sometimes the interview happens, or maybe you will be evaluated, like you will be given a the output of the data, and you would be asked to do portray or maybe to do storytelling, right? So that is one of the skill which is a data scientist skill plus a machine learning skill, how to do explain the output. Because generally one of the blame for ML and AI as on today is that they are complete black box. Unless somebody is able to completely do a storytelling out of that particular, do a narration out of that particular, what this model is telling, why it is telling so, and what are the possibilities of the variation, right? Around what is the confidence interval around what kind of output it is giving, right? You know uh, at what level we should treat this model as accurate, why we, what are the downsides, where we should read some of the output of a ML model with a pinch of salt. So all this storytelling, which as a machine learning expert you do to your uh, regulators, you do to different stakeholders, auditors, you do to maybe your model validation teams, you do to your model approval committee, all these storytelling, because they need to understand the model better in order to, for you to get their nod and approval. You need to do a good storytelling, and that is more of a creative skill, how to do storytelling. So that is again maybe how to put facts, how to statistically back those facts, right? How to maybe highlight some of the areas which could lead to model variability or model stability issues, right? How to maybe assure that the ML model will be uh, will be auto calibrated. And what auto calibrated means, you every time you need not to redesign the model, or relook at the data. As long as the data keep coming, the model will keep updating itself with the new parameters. It will auto parameterize, it will auto calibrate itself. What goes into that? Because a regulator who is approving the model, a auditor who is auditing the model, uh, you know an approval committee, model approval forum who is internally vetting the model, right? All of them need to understand these facts very clearly, and you need to do a lot of storytelling in that. So that maybe in a way maybe broadly covers the spectrum of skills or core competencies which are desired. And so it is a multifaceted job, right? That's why it's not just one thing, but it's a full total way you need to develop, hone these skills, right? Borrow it. Some of those skills are borrowed from computer science, some of those skills are borrowed from statistics and econometrics, and maybe the probability theory. Some of those skills are borrowed from linear algebra and mathematics. Some of those skills are borrowed from domain, the understanding of the domain. Some of those skills are borrowed from how you do dashboarding and data visualization and use that for storytelling, right? So and some of those skills are also borrowed from maybe your understanding of the what kind of problem it is, first of all. So predictive analytics, whether it is a regression problem, should it be treated as a regression problem, whether it is a bivariate multivariate regression setting, right? Whether it is a polynomial regression, whether it is a time series regression, whether it is a classification, whether it is a clustering, whether it is association. So all these aspects coming together make you full bodied machine learning expert. And that's as people say that it's a 21st century most desirable job and one of the highly paid job. So the challenge is no less, right? So you need to maybe hone yourself in multiple direction. So as machine learning is touted to solve high dimensional problem, multi-dimensional problem, so it is desired of a machine learning expert to be multi-dimensional and to be able to you know uh, talk about talk as an expert or as a subject matter expert of machine learning from different angles, right? When a problem is given, the machine learning expert should be able to you know talk length at the data augmentation, data manipulation, data mining, right? All these kind of pattern detection skills, they should be able to clearly articulate, marry the data for its relevance to the problem at hand. They should be able to specify the application use case of that particular data to the problem at hand. Then obviously programming skills, all of it should come together in your pitch to be a machine learning expert, or in order to demonstrate your core competency as a mid-career machine learning expert in finance. So that's the moot point over here. So maybe let's maybe see, maybe because for the benefit of those people who haven't even broadly understand the machine learning itself, and what are the different layers within it, right? This maybe just covers what it is. So some of these topics, so we need not to confuse, like some of the jobs say data scientist, some of the jobs say machine learning expert, some of the jobs says machine learning engineer, some of the jobs says machine learning ML ops expert, right? Some of the jobs, so different jobs, or some of the jobs is data mining expert. So some of these things are interchangeably used, right? But they are broadly part of the machine learning, data science. So but there are certain differences which you need to acknowledge for yourself, right? So basically the data science work or the data scientist work, uh, uh, so the if you follow through the entire stack, front to end of life cycle of machine learning, the work starts with data mining, because over last decade or two we have seen a data revolution. We have now terabytes of data flowing into our data lakes, right? And we have now all the technology to handle this big data, which is coming in huge volume, in huge variety, in huge veracity, uh, you know in uh, in huge in high velocity. So all these data which is coming to us with all these v's: volume, velocity, variety, veracity, right? All we have the technology, we have the data lake structure within our firm. The problem is no more the data. The problem is that how to mine that particular data for a meaningful conclusion, which will drive your strategy or drive the decision making across the firm, right? That's why most of the firm do not have paucity of data. They do not have dearth of data. They are sitting on piles of data, right? And added to that is that we have unstructured data as well, like uh, the social networking sites, the data coming from social networking sites, the data coming from tweet handles, the data coming from video and image processing data, right? So we have a lot of unstructured data as well, besides the numerical data which we used to have, right? Banks have all these unstructured data as well, which we call unstructured data, because they come in the you know in the form which we have never seen, like maybe your speech processing data, your maybe image processing data, your uh, you know language processing data, y- all of it, your tweet, your social networking data, tweet handle, opinion analysts expressing their opinion on a particular stock on the tweet handles, and the market sentiment is going haywire. So the sentiment analysis data, so a lot of data is there, right? Both traditional form of structured data and untraditional unconventional form of the unstructured data. But the problem today is how to mine this data, and how to then apply certain data science concepts to draw meaningful pattern detection uh, within the data, so that you could then first of all assert for yourself whether data is useful or not, because this data, the new form of the data, is very very heavily noisy. There are few patterns and there's a lot of noise, right? So pattern detection, as we just touched upon on the previous slide, is very pivotal, right? To be able to start applying the machine learning algorithm or techniques to this new form of voluminous high frequency velocity and variety of data, structured and unstructured, which is less reliable, right? More and more less reliable. But we got to the new mantra of strategic success for a firm is how to make sense of this particular data, right? uh, so data science concepts are applied on top of it. Then comes the machine learning. So a data engineer, a ML data engineer or a data engineer in today's world do the data mining job, right? uh, how to bring the data into these big data platforms, right? How to organize the data, how to structure the data, right? How to process different forms of data through different maybe technologies. Like image processing data would require different technology, speech processing would require different technology, text processing would require different technology, so on and so forth, right? So a data scientist marry the data and to have some coherence. Like suppose if I'm building a market sentiment algorithm, right? Would definitely require all the opinions from the pundits or from the analysts which were expressed on different stocks and stock indices on different platforms, including Twitter handles, right? So how to marry that particular thing to build a sentiment indicator for the market, right, is a data science. That particular manipulation of the data, is done by the data scientists, right? So when we talk about manipulation, it's a exploratory data analysis or analytics phase, which a data scientist take the data through. And it the data scientist cleans the data, transform the data, manipulates the data, aggregates the data, maybe granularize the data, decompose the data, a lot of these things, right? To detect the pattern, and to then maybe uh, once the pattern is detected, once the pattern is clear, once we get to know that this data is now relevant, that skill then get transferred to a machine learning expert. And both data scientists and machine learning could be seen together as well, because a person who knows both, or who reasonably knows both and covers the ground on both sides, could be called a data scientist as well as machine learning expert, right? So a machine learning expert now knows that, having this pattern, right, what kind of algorithms, what kind of ML techniques I should apply, whether I should apply supervised learning techniques, semi supervised learning techniques, unsupervised learning techniques, reinforcement learning techniques, deep learning techniques, what kind of algorithm. And within those paradigms, the supervised, semi supervised, unsupervised, deep learning, reinforcement learning, there are different techniques, which technique to apply, right? So that's the intelligence which is brought by or the core competency or the skills which are brought by the machine learning experts, who know their use cases well, who know which techniques work for those use cases, who marry the data, the application and methodology together, right? So the data which is already produced in a meaningful way, to have some key patterns or some substantial patterns in that, how to marry the data with the methodology, the domain methodology, with the ML techniques and with the application of ML techniques. So it is marrying of everything which brings up a machine learning model. And then that machine learning model is sometimes optimized, deployed, right? And then we get the final uh, real time analytics, which is the promise of this machine learning model, right? So it requires a lot of maybe journey, maybe right from the scratch. And some of the when I refer to the programming skills and how it is being referred on different maybe you know job requirements or JDs, job descriptions, right? You should read it this way, that it is a full stack understanding, right? That many of the new databases, the big databases, new databases like uh, possibly SQL or MongoDB or DynamoDB or MySQL. So these are or maybe the distributed storage technology like how Hadoop, Spark, you know, Flink, these Apache, Flink, these work, right? So this, the first is that you should understand, even if you are not expected to be a data engineer or to be a some IT professional who would be doing it, but you should understand how the new data is handled, what are the big technologies available, how the new distributed database is designed, right? So this covers maybe the initial leg of this front to back uh, you know uh, application development. So the front to back application development would first of all require you to harness some of the technologies which are available to handle the big data which is coming at large volume, huge velocity, high velocity, right? In very diverse variety and veracity, a lot of from unreliable sources, like maybe from Twitter, from those are unreliable sources which which for regulatory purposes, if you are building a model and bank is a regulated entity, you cannot simply declare those sources as reliable. You have to do your own data engineering steps to make the data reliable, right? Then maybe requires a lot of what are the technologies involved in data cleansing, data scrubbing, maybe data some of the ways of eliminating noise from the data, eliminating the errors from the data, eliminating handling the extreme values in the data, handling the missing values in the data, right? So some of these would definitely require the analytics languages, which nowadays have become, it's predominantly being done in Python. So previously it was in SAS and R, but most of the trend is that it is moving and migrating to Python, right? So Python would handle it. Plus within the Python, what are the data wrangling tools? So how to use the pandas library, which is one Python potent library for doing data manipulation, data cleansing step, data transformation, all of that, right? How to use those particular libraries. So that's also, you need to understand specifically if you want to target for a job which requires somebody to be in a data science position, data scientist position, right? So that's here. Then obviously once you are able to do all of that, you are able to clean up the data, right? Apply the required transformations to the data, right? uh, Aggregate the data at the right level, or maybe de-aggregate the data, decompose the data at the right granularity. You are going to explain in a forum, you're going to explain what data tells you, what are the data key insights. So that is the job of a you know they're either a machine learning expert or a data scientist, an experienced data scientist, because you need to explain it in specifically in the domain terms will come, which will create, who will create the dashboards or some of the visualization you know uh, visualization interactive reports, and some of the technologies which are involved in that. The Python has its own dashboard, right? Building app capability. Similarly, MATLAB and R and there are some new technologies, Vika, which have a lot of data visualization capability. So how to show the trends and patterns, uh, and the decompose the data, and maybe filter the data, how what kind of pattern you should show to your uh, the decision makers. And then the decision makers will, along with you, will seek your expertise, what kind of different techniques could be relevant and could be applicable for that particular kind of data and the kind of the use case you are talking about. So then maybe you would need to understand that within these scripting analytics languages like Python, R, or SAS, or Julia, or right, some of these, what are the specific libraries which where the machine learning techniques are built, right? You need to understand the inner working of those particular techniques, right, to be able to prove yourself as somebody who can do a machine learning model built out on or machine learning prototyping, because then you would be calling methods and techniques from certain library, machine learning library within each of these scripting languages or analytics languages, and then obviously interpreting the results, like how to you apply your statistical inference or probabilistic inference on top of what kind of results you get out of a machine learning model, and then explain it in a very succinct way or in a very precise way to your main stakeholders from whom you are seeking the model approval, be it regulator, auditor, model validator, or external auditor, different teams or different stakeholders who would be party to approving that particular model, right? So this requires somebody to understand, and specifically we have designed the course so that not only we would be focusing on uh, making you understand the scripting language, but of the full stack, front to back stack of the ML ops, which we call like DevOps. There's a new term which is coined for machine learning, which is called ML ops. So ML ops is nothing but operationalizing all the steps of model machine learning model built out from front to back, the front to back integration of machine learning model lifecycle journey, implementation journey. So that's called ML ops. So maybe we would maybe cover it maybe along with the technology at each stage, at each phase, at each step, what kind of technology and tool sets are used and what they are doing with either the data or the model, or the maybe some of the optimization, whatever how we proceed ahead from front to back in creating a full application, right? So it is part of the software development lifecycle or the application development lifecycle for machine learning, right? You need not to just know the middleware, you need to know the frontware and the back end as well. The both the front end, back end, and middle end, all are equally important for you to become a full stack ML uh, designer or ML expert, right? Now the next obviously is the the domain part, and this is the most important part. I would rather say that obviously there are machine learning flurry of machine learning courses, data science courses here, there, everywhere, right? And obviously they are good, we would not say, right, they're equally good, because many of us, right, have joined those courses or planning to join those courses, they're good, right? But the point is this, that there's a dearth, or there's a complete ignorance about the domain aspect, right? When somebody is working in finance, he cannot be just trained on a any generic data set, right, from any other industry, right? And then even if he is trained, he will develop some certain proficiency, no doubt, but he would then find it equally challenging to apply the same machine learning technique or a financial use case, right? So that part led to maybe us designing this course, where we gathered tapped into our use case library, gathered all the financial use cases which are applied to trading or algorithmic trading or high frequency trading, portfolio optimization, risk management and hedging, right? Your derivative pricing, all of uh, these problems galvanize into creating a huge use case library on which we should try or attempt. We are not maybe promising beyond what we could deliver, but we should try and attempt, because these are some new areas, application areas, and knowing them how to handle it is in itself a USP for somebody who is trying to find a career, long term career in machine learning. It's a huge USP that you should, forget about all use cases, at least 2 3 use cases, and you have done your capstone project on those particular use cases, right? Both you have covered the data aspect, the model aspect, the predictive analytics or modeling aspect, the machine learning alternatives, and proven that the machine learning alternative is better than the conventional way of doing modeling. If you have done even for 2 or 3 use cases, right, most of the battle is won, because that would be your USP. Today the job market has changed. You got to realize that it's more about demonstration and prototyping, right, then about writing that you have done a particular certification and the machine learning techniques. It's more about demonstrating. And the further, the machine learning is such a broader area that within that there are sub domains, there are sub expertise. Somebody is expert in supervised learning, somebody else is expert in unsupervised learning, somebody is expert else is expert in deep learning. So it's not just knowing everything is good, but at a later stage you need to be very focused, lens focused. Okay, being my experience, my level of interest, right, my financial use cases which I come across would require me to develop you know capability and core competency and skill in this particular domain, in subdomain, right? And then you need to do some prototyping, do some project, do some front to back, right, model built out to to make for your case, and then the case is sold, right? Generally the interviewers would like to see that what kind of work you have done. So it's a demonstration of the know-how, the technical expertise, as well as the domain expertise, as well as the data understanding, rather than just saying that okay, I know the techniques which are part of the machine learning, which is how you know uh, we want to differentiate. Because we being maybe somebody, a trainer or long from for a long time, we being trainer in topics of financial engineering, quant finance, risk management. So we know those use cases, and we leverage those use cases to build certain machine learning specific applications, which could be maybe you learned, and these are further evolving, right? These are further evolving. We would not claim that uh, we have reached the pinnacle, because it's the industry is evolving. Even banks are experimenting, financial institutions are experimenting, most of the hedge funds or different kind of funds, managed funds, hedge funds, right, proprietary trading firms, they are experimenting, fintech industry is experimenting. So are we as a trainer, that we are experimenting with some use cases, and which are very pervasive use cases, and which are uh, somehow we call low hanging fruits of machine learning adoption within the financial industry. So that's what we want to maybe achieve. And some of these use cases maybe uh, this is not an exhaustive list, first of all. And again, the second point is this is not something we want to just limit ourselves to, but some of these use cases which we generally come across, which feature most of the mid careers, machine learning or data science problem set are highlighted here, right? So you could have these particular use cases maybe in your head, clearly in your head, while taking up any career, and maybe that which particular use case interests you and where you want to build your expertise. But we would be in through our different modules, we would be having these specific use cases as part of our modules, to cover these different machine learning techniques use for each of those use cases. So it's not just one machine learning technique, but we will discuss different machine learning technique application for each of these use cases, right? So that's maybe the intent, right? So as you may see, so if you further maybe categorize the broader application of machine learning in finance, you need to understand very clearly that if you are risk management professional, right, you got to look at, pick up your specific subdomain accordingly, that which particular subdomain you would like to do your capstone project or some kind of a model prototyping, right, what interests you and what kind of things are aligned to your career aspirations. Similarly, if you're a quants guy, who is do more into the pricing models, you need to pick up your asset class or specific use case where you want to do this, right. And similarly, portfolio, if you are on portfolio management side or trading side, we can maybe uh, further categorize, catalog those use cases for a better mind mapping, so that people are not confused that okay, as is the case with maybe in general, that today there are a lot of trainings, but you know relevance of those trainings need to be further enhanced in order to make them more use case specific, more practical and pragmatic to the specific area where you are pursuing your career, or where you want to see your career journey going ahead, right. So that's maybe a bit of a mapping and catalog, right. uh, and then eventually I told you maybe all these somewhere this pattern detection, predictive analytics and performance optimization skills, they are more or less mostly about knowing the mathematics, statistics, and probability uh, theory of the models, right? So the mathematics is not that much. So even if it is, too much for you, but we have dedicated primers to cover the detail of the mathematics, statistics, and probability as a prerequisite to the start of the any module, right. So you will be you know practicing, covering these concepts and details. So it's not a blocker, or it's not a mental blocker, moreover, because I can, on a daily basis we interact with students, and we get that maybe they want to do this thing, but it's been a psychological or mental blocker that they have never read mathematics in the grad classes, they have never done coding in or programming in the grad or master, uh, when they were pursuing their graduation or master degrees. So that's not a blocker, first of all, right. The world is changing, we need to change. The only thing is that what we should do is we should clearly put our mind through that we should learn it in the right way, right. That's the most important thing. And learning in the right way and honing a skill and developing the core competency require you to learn from scratch. And we acknowledge that, and we, in recognition of that, we are creating exhaustive primers which will go which will be module zero, so to say, but it will go parallelly as we go ahead in our journey. Every module would have some mathematical, statistical, or probability primer or programming primer, which would further make you prepare for that particular module, going into that particular module. But obviously, right on day zero, you would have some ground up work, uh, which will be enabled by through multiple primers and preparatory modules, which will make you build your conceptual thing, like multivariate analysis, or some of the topics like linear algebra or matrices, right. Which would be very much required. Forget about machine learning, but they will be equally required for a quant finance or a risk management professional. They need to understand the mathematics, statistics, and probability theory behind the models. So that's the intent, maybe. And that's where maybe we would like just one thing. So the pattern detection, right. So maybe what I have already covered this, but just to put few maybe sentences to it to make it clear, right. So the pattern detection technique again is the moreover the data manipulation, the data science, and the statistical inference skills, right. In machine learning, sometimes this is you know uh, this is a bit, uh, the parlance of machine learning is a bit different. It's easy than the pure traditional parlance of the model, but the terms are slightly different, right? So you talk about in pure AI terms, like what is the sensor? Sensor means the certain you know certain variables in your model, or certain features which you have captured in your model, right? Which basically which capture the pattern. That is the sensor, right? How that sensor has been trained, how that sensor has been trained to be adapted to predict, right? That's the pre-processing or the data science processing which you have done, right, to use that particular sensor and to build a functional form or a relationship between your predictors and the predicted variable, right? And then the feature extraction. Features are nothing but variables, key variables, which are used for finally forecasting or predicting or your variable of interest. So once this is done, then I told you that predictive analytics skills would require you to map it to regression, time series, classification, clustering, association. And then basically thereafter, somebody who is you know building this model will be doing some performance optimization on top of the finally selected model, after applying a particular machine learning technique based on whether it's what kind of problem it is it a regression problem, time series problem, what kind of regression problem it is. It could be further divided, but regression problem, time series problem, or maybe classification problem, clustering problem. You apply a relevant machine learning technique, whether you apply neural network or you apply support vector machine, you apply random forest, right? You apply a machine learning technique, and then once a machine learning technique proves itself better than the classical traditional conventional way of doing the same modeling using the statistical techniques, so it proved better that the champion model, which was built on the statistical model, built as a statistical model, uh, is less accurate or less precise than the challenger model. The challenger model is the machine learning benchmark model, right? So once it is proven, that hypothesis is proven, then finally we will fine tune that particular model for the final productionized deployment, and we will do some trial and error to make that model meet the promise of what I call the real time analytics, right? So that's the journey, and that's maybe where the skill lies. And maybe that this particular, as I said, that this particular series start today, so we thought that first of all we should cover the recipe, because we are going to have some role plays in the subsequent session. The role plays of which depicts how a career skill, machine learning career skill, could be displayed for different role families within the financial industry, right? So we would have certain role plays, sort of live interactive role plays uh, planned for the next few sessions. But having this broader canvas, understanding of this canvas, whole canvas, how things are working, right? How we should see the career journey, how we should see these career skills, how we should see these capabilities and core competencies, and how we should map it in our mind, how we should do mind mapping of how they're mapped to a machine learning way of doing modeling, right? Is what we want to intend to cover. And hence, if you can see on this slide, maybe by 2035, there's no doubt that the machine learning is pegged to save 1.2 trillion worth of cost. And that's the reason why BFSI industry is all gung-ho about adopting more of machine learning algorithm. And it's no surprise that the doomsayers have now turned into maybe naysayers, and they are also saying that okay, this is the way forward, because previously that regulators were very hawkish, very pessimistic about machine learning, very doubtful and dubious about machine learning. uh, Now their suspicion has been addressed, and they are themselves changing. You must have understood that the fintech company is evolving, which is challenging the mainstream banking. Similarly, the regulatory bodies, the likes of Prudential Regulatory Authority or European Banking Authority or Swiss Regulatory Authority called FINMA or Monetary Authority of Singapore or Fed Reserve, all these authorities are also evolving, and they are designing their own new version of the tech-driven or ML-driven, uh, you know, uh, uh, regulator, which is called the RegTech. So we have fintech coming, we have regtech evolving, and there's no doubt that tomorrow we would have uh, full throttle adoption of machine learning, all across different walks of maybe the risk, treasury, finance, compliance, different maybe areas of banks, right? And by 2030, any which way, which is a short term target that BFSI is touting, maybe to reduce costs by 22%. And these are not my research, these are basically I borrowed from BCG and McKinsey research, right? And some of the renowned IMF and World Bank researches as well, that maybe World Bank says that the future of jobs report in 2020, they says that AI will replace 85 million jobs globally by 2025, right? This is, they said, specifically, you know with respect to the frontier industries, including the finance, right? And then these are the roles, BFSI roles, which are reshaping this new shift, paradigm shift from the traditional role families to this ML AI driven role families. So we have machine learning algo designer, machine learning product owner, machine learning developer, machine learning researcher, who's somebody who knows the techniques well, machine learning techniques well, and their application well, the data scientists and the data engineers. So these role families, you will see more and more coming, and will be seen with higher price tags, right? Right, if that at all maybe motivates anyone, right? So anything which motivates anyone should be uh, taken as such, right? uh, okay, so these are the role families, BFSI role families. How you will see that there would be many roles which would be coming up, aligned to AI ML data science role family, right? And the with the most roles which are demand in short term are the data mining, machine learning data mining, machine learning algorithm building, and machine learning optimization and explainability, right? So those skills are very much in demand, and I have covered a few of the industries, industrial applications, from where maybe we could see that many of these upsurge of jobs and careers are evolving, right? So just maybe the derivative pricing is one key area, algo trading and high frequency trading is another area. Portfolio risk is very area which, if you see Google it, machine learning or techniques for portfolio risk, you will see a lot of research happening in this area, right? Similarly, how we determine the capital adequacy topic for Basel, right? Under Basel 3 or the new Basel 4, the finale of Basel regulation. So all these topics like market risk, credit risk, counterparty credit risk, ops risk, the capital determination or capital adequacy calculation is now maybe seen that how we could use machine learning to determine the regulatory capital, which is the risk weighted assets, as well as the economic capital, right? So that these are the evolving areas. The financial time series forecasting problem is also maybe an evolving area, not an evolving area, but is rather a settled area, sorry, right? Because we have done already a lot of price forecasting problems, return forecasting problems, and volatility forecasting problems, and loss forecasting problems, and the PNL forecasting, financial statement forecasting problem, like PNL and balance sheet forecasting problems, using machine learning algorithms, which is a pretty much settled area. So if somebody wants to try their hands, right, in what has already been done, enough so that they would at least get an entry into the AML jobs coming in the BFSI sector by leveraging upon, right, what is very much pervasive all around, that is the financial time series forecasting problems, right? And then maybe obviously we have a lot of chatbots, not lot of natural language models, which we call language models or natural language processing models. We have a lot of chatbots which are being built on the front office side, where we specifically the portfolio management side, or maybe the client management side, with the multiple chatbots and compliance chatbots are there. There are multiple chatbots which are built, and the natural language processing is again a area which is picking up, and that area is not specific to BFSI, but that area is right across the industries. NLP is right across the industries. It's the lowest hanging fruit, where somebody who is looking to automate the process, right, any process which is manually laden, which involves a lot of a lot of documentation, a lot of governance, right, has been taken up by NLP, natural language processing. So that's the area maybe, and at the core of it you could see that mathematics, statistics, computer hacking or computer science skills, right, and obviously all of it would be underpinned by the substantive domain expertise, and the risk management, and the quant finance knowledge, and the uh, good understanding of the use cases, application use cases, is what I think is the success mantra maybe. That's what how I read it, that's the success forward maybe. And it doesn't only require you to lean in one direction or the other. It requires somebody to be uh, seeing at machine learning as a multi disciplinary profession, or multidisciplinary field, where they need to have multiple skills to be able to sustain and grow further. So with that, maybe I'll take a pause and maybe give people opportunity to maybe ask question and make it more interactive. That's also the key intent of these sessions going forward. Yeah. So Nitish, maybe
Oh,
over to
wonderful.
you if you could. Yeah. Yeah.
Yes,
Thanks.
wonderful. I mean, that was like a pretty informative session, Sanjay, as always. But maybe before going into the Q&A, we'll give you like a 2 minutes breather, where actually I would like to take the opportunity to briefly introduce ourselves as well at IIQF. Okay, so I'm just changing the presenter to myself, and I'll give a brief intro, and then we'll take up the questions one by one. I hope my screen is visible. Right. So before we go into the Q&A session, I would like to take this opportunity to briefly introduce all of you about our institute, the work that we have been doing for more than almost 1.5 decades in promoting the field of advanced financial analytics, which it's started with the quantitative finance and financial engineering domain. So we are an educational and training institute dedicated to training and education in quantitative finance, financial engineering, management, quantitative algorithmic trading, artificial intelligence, and machine learning. Right. So we were founded by pioneers in India and top experts from the field of financial risk management, financial engineering, investment banking, and as an educational institution, we have been focusing on promoting education and training in the field of all these domains, right? If financial engineering, quant finance, risk management, algo trading, derivative products and valuations, artificial intelligence and machine learning, and several all other areas of modern finance for more than a decade. And I mean, as Sanjay has mentioned in quite a deep, so we have extensive collective experience in various application areas of advanced finance. And I mean, that's one of the main reason we have thought about bringing all our expertise and experience in like having a course specific to machine learning applications in finance, where we will be using our all the case studies and all the application areas that we have worked on to teach machine learning as applied to finance, right? And not only in machine learning, I mean, just to briefly, I mean, we have a few courses which are pretty extensive courses for people who are interested in various areas of advanced financial analytics. Of course, we have a specific course on certificate program in machine learning for finance, which is eight months course, which Sanjay has also briefly introduced, which is a course designed to teach machine learning and data science in context of the applications in finance. For somebody who want to learn the skills of quantitative finance and risk management, we have a 6 months course called Certificate Program in Quantitative Finance and Risk Management, a very comprehensive course that deep dives into both theory and practical modeling for derivative valuation and risk management. For those who are interested in going deep into the mathematical modeling side of finance, so we have a course called Certificate Program in Financial Engineering, 7 months course where we comprehensively cover both or rather we go deep into the theory and practical mathematical modeling for derivative valuations and risk management. And further, we have for people who are interested in learning about algorithmic trading, which is in terms of trading, it's like a what area as well, right? So we have a couple of courses in that. So we have a 8 months course called Postgraduate Program in Algorithmic Trading, a course which teaches all aspects of algorithmic trading using technical analysis, machine learning, and quant models. And we have a 4 months shorter certificate program in algorithmic trading, where we teach all aspects of algorithmic trading using technical analysis. Right. The machine learning module Sanjay has explained in deep. So anybody interested in like furthering their career in machine learning for finance, you can utilize our course to make your career. The machine learning for finance, the career track, though Sanjay has already explained in deep, but like again, just to summarize, what are the potential career avenues which are available in the industry for aspirants of machine learning programs? The machine learning program caters to building practitioner level skills to broadly cater to any and all machine learning and data science driven role families, with few examples from the job market which are given for your understanding. So you can become a data scientist for financial accounting decision systems. You can go into machine learning model designing for financial forecasting and predictive models. You can be in forensic audit data scientist. You can be a fraud analytics machine learning expert. You can go into risk finance compliance based machine learning data engineer jobs. You can be into machine learning modeler for quantitative finance models. You can go into machine learning driven algorithmic trading, or you can be a machine learning model validation expert. The list is endless, the scope is huge, and these are just like a few areas which actually we would like to mention, but again, it's a huge area to explore. I mean, so it has been a very I'll say a satisfying journey of more than 14 years. It's almost 15 years now, where we have been promoting quant and financial engineering and risk management related areas in finance. And so, I mean, a lot of students and professionals have passed out of the courses and have some of them have we are glad that they have shared their thoughts. I mean, you can just go through the thoughts that they have shared in our testimonial pages, just to understand how people can utilize this to uh, further build their careers in different areas of financial analytics and machine learning, right? So you can go through them. Testimonials are listed briefly. These are like few we have brought in here, but just to show how people can utilize this courses to make a further dent in their careers, right? So in target companies, of course, I mean, we are talking about advanced financial analytics. So target companies will be companies like hedge funds and financial technology, DSO, Citadel, Millennium, investment banks, Goldman Sachs, Morgan Stanley, Deutsche Bank, commercial banks like JP Morgan, Citibank, Nomura, stock exchanges, NISC, NSC, consulting firms like EY, Deloitte, PwC, IT companies, Accenture, Cognizant, TCS, And further, if you are doing machine learning related course, then of course, I mean, these are like examples of only the bigger financial institutions and related companies. But again, the scope is even more wider. You have a lot of the fintech companies that have come up. You can of course go into, I mean, lot more areas. I mean, even as Sanjay mentioned, right, learning machine learning, again, if you want, you can shift to other domains as well. You may not necessarily stick to finance, right? So the scope is huge. I mean, a lot of very uh, wonderful opportunities can be availed, right? So I'm not going into this. And yes, and like our long work experience, we have been fortunate to be associated with the big financial institutions like BNY Mellon, Thomson Reuters, ING, Capgemini, Bombay Stock Exchange, LIC, Citibank, NSE, Globe, Society generally, to name a few. It's a long journey, and this is just like a very small list, very difficult to bring all the list. Pretty much we have worked with most of the uh, bigger known names that you actually have in the industry. Yes, and in our endeavor to promote this field, we have also worked with leading educational institutions like IIT Bombay, BITS, Pilani, NITI, to name a few, where we keep on doing our work in promoting this field of quant finance, machine learning, and related areas. So in any case, if anyone gets interested in exploring more about our courses, you can connect us through our website, www.iiqf.org. You may call us on the number mentioned there, 8976993622, and you can email us to this email ID, info@iiqf.org. Right. So with that, we will go into the questions that you all have put up. I mean, we will take up the questions now. So Sanjay, I'll be collating the questions one by one, and then again you may address the questions.
Yeah, sure.
Yeah, sure. Just give me a moment. Right. So first question is, okay. So Sayan has mentioned his purpose of joining the program was is an engine system engineer working at TCS, and he joined the session to get idea about where to begin with machine learning and artificial intelligence. So I hope Sayan, you got the answers that you were looking at. In case you have any further queries regarding that, please feel free to put up your question in the chat window. We would be happy to take up. And so in the meantime, let's go to the next question. It's from Michael, and Michael says that what new roles have been created around AI and ML? Example, apart from data scientist and machine learning engineer, are there new ML focused BA and product owner roles? How would one get into those roles? So I think anyway, Sanjay, you have addressed this question to a lot of extent in the during your session. But again, if you want to add on anything on that.
Yeah, that's an interesting question, Michael. I think you are more asking from the CTB side, the change the bank side, that what new roles are emerging to which are aligned with the AIML, adoption, right? So look, maybe there's one thing in understanding and developing and designing those models which are pure ML, researcher, ML scientist, or ML domain expert, or data science roles. There's a parallel stream of roles which are specifically on the CTB side, because once these models are developed, these need to be implemented, right? And the implementation would require in under the new agile way of doing things, or agile framework. Gone are the days when people used to do waterfall uh, software development life cycle. Now people are doing it in an agile way, or rather kanban way. So there would be a product owner role. The product owner role, definitely ML product owner role, definitely would require they would not need not to be hands on prototyping, but they would definitely require a skill to understand all the ML techniques and their application to the use cases, right? Because they would be providing certain sign offs from a product owner perspective, or maybe they would be conducting few UAT testing, user acceptance testing of the models, and blah blah blah. So the point is this: yes, it's similar to how the business analyst role family, the scrum master, and the product owner role have evolved for the traditional models, which were statistical models, which were once developed and then implemented, and there were all these CTB side, change the bank side role families, which drive the implementation of those models. Similarly, on the ML side as well, these across fintech companies, across different data science firms, these roles are very pervasive, which would definitely require you to be understanding the ML and data science bit. Yeah.
Yes, absolutely. And so I hope, Michael, that answers your question. I mean, in case you have any follow-up question, you may put up in the chat window. We will take it up as well. Uh, so in the meantime, Somadip has a question. So he says that I'm a trader currently learning machine learning and algo trading in Python. I would like to know skills required and scope of ML in quant trading. So yeah, there's a question. Would you like to add something on that?
Yeah, so that's again a very maybe well informed question and well directed question maybe. So
Sure.
what we have seen so far is that the algo the trading and specifically the trading strategies, the designing of trading strategies uh, have been hugely disrupted by ML, right? So the ML has multiple use cases in designing different strategies like event driven strategy or global macro strategy or volatility, stochastic volatility trading strategies. All these strategies are now maybe designed using the ML algorithm, right? The main reason is that many of these strategies need to be recalibrated and very frequently adjusted, which was very difficult while designing it using the statistical models, right? So your question was that what are the opportunities and use cases in this area. There are a lot of opportunities, and this is one of the area which is the front runner area of machine learning adoption, because one of the reason is that there are still less impediments to it, because the regulator is not regulatory driven topic. It is a bank's internal application of the models, where what kind of trading strategies they want to pursue, how they want to design it, how they want to maybe recalibrate it. So that's why maybe a lot of ML models are being built, and ML researchers are being hired in this area.
Yeah, absolutely. Absolutely. I hope that answers your question, Somadip. And I mean, if you want to do have any, if you have any follow-up, more query on that, you can actually put up in the chat window. So Michael has a follow-up question. So he says that he's is a BA data analyst focused on data acquisition, and he has 20 years plus experience as a BA. But he
Mhm.
sometimes feels that machine learning is for younger people or those with PhDs. So,
No,
any
no,
thought
not at
on
all.
that?
Right. So to be very clear, I'm not the PhD, right? Right. Though I have a good 15, 16 years of experience, but that doesn't make me PhD, right? Right. So the point here is simple, Michael. The technology, since you're working on the data side, the technology if you tomorrow, let's presume you move on to the machine learning side of things, the technology or the tools would completely change. You need to maybe make yourself well familiar with those new tech stack and the tool set, right? So once you are able, so there are two things. One is you switching to a particular domain which is evolving, emerging, and there are a lot of opportunities. From traditional data engineer you will become ML data engineer. That's the one journey. The second journey is how to move up the value ladder. You are a data engineer, you would like to definitely if you have aspirations, right aspirations and the right mindset, if you would like to definitely move up the ladder and become the data scientist, because you have 20 years of experience, right? And the data scientist role family is not for the entry level, right? It's for somewhere leaning towards experience, few years of experience in the industry, and at least a great deal of what you are doing, right? So you would have two-way growth, a vertical up the ladder growth, which is you moving up the value ladder in terms of your value chain from data engineer to data scientist, as well as a parallel shift of moving from a traditional data engineer to a ML data engineer. So that's the two tracks for you, and definitely both the tracks will be paved by doing a ML course, right? And that's for you to decide which one suits you. But if you are in finance and then definitely we have a lot of use cases to cover, and the theory and concepts to cover which are applicable to finance and BFSI industry.
Absolutely. Right. So I hope that answers your question, Michael. The next question is from Vinod, and he has asked, like, do we have a functional and technical separation like in ERPs? So that's the question. Would you like to take that up?
I don't get the question. In enterprise risk platforms, what is ERP like?
Yeah, I mean, Alok, you can actually explain the question a little bit more to Sanjay if you are there. I think ERP means the ERP systems that Vinod has
Okay.
talked about. Am I correct, Vinod? Vinod, if you are there, I mean, can you clarify that? I mean, you mean that ERP is like the enterprise systems that you are talking about?
Is it like SAP or these systems which he's referring to?
Yes, I think so. That's what he is referring to. So, Vinod, if you are there, can you clarify? Mm, so Vinod is not responding actually. So anyway, in the meantime, let's probably go to the next question. The next question is from just a minute. Let me check. Yeah, SAP, etc. That's what he meant. He has responded now. So basically, he's means like all the enterprise risk planning systems like SAP and all. So there
Okay.
actually he's mentioning that
Separation of
that
technical and
there
functional.
yes, so they have a very defined functional and technical separation in ERPs. So do in ML also that kind of separation is there or not?
So it's so the ML is not a sort of a standard. There's no standard like SAP is a standard, or there are some ERP applications or softwares which are have become over the time standard across the industry. It's not that the case with ML. ML is very much emerging, and people are developing it in different way. But what I can say that this, where things are converging or at least getting standardized is ML ops. Like the way you build a machine learning application, that the steps are standardized, but how you build the components, whether how much modularization you do, right? That is not standard practice, and generally sometimes based on what kind of firm you are working for, right, you might modularize it more or not. what I mean is like pricing. If you want to modularize it even at a subasset class level, at a even at a risk factor level, you could modularize it obviously within, because now we have all these ways of maybe modularizing the code, and that is the way the code is developed nowadays, the system is developed nowadays, but it's not a standard practice in ML models. Yes, but the other part is technical and functional separation to an extent is there. Yes, the technical and functional separation is there. The functional modules are different and the technical modules are entirely different.
Yeah, absolutely. I hope that answers your question, Vinod. I mean, do you want any follow-up explanation on that, or were we able to answer your question? Anyway, so we will take up any follow-up question that comes from Vinod. Yeah. So, but in the meantime, again, going to the next question from Santosh. So Santosh has asked, do you have or going to have soon any MTech or MS degree program in FinTech? So Santosh, we as a body, we are more into certificate courses at this point of time, right? I mean, we are not immediately we are not going into the degree courses like MTech or MS. But said that, there are a lot of talks that are going on with some of the foreign universities, and we might collaborate with them and offer some master's degree program going forward. But nothing concrete at this point of time. It's in an exploration stage. But like for the last 15 years, we have been conducting very serious, comprehensive certificate courses, which actually prepares you for jobs. And a lot of people have utilized this to uh, enter into very advanced profiles in quant risk, machine learning related profiles. So, I mean, but yeah, these are not degree programs. These are all certificate courses. As I have mentioned earlier as well, these are all weekend live lecture based courses which you can do along with your job, or I mean, along with any other degree that you are pursuing. But yes, I mean, there is some exploration definitely going on with some foreign universities, and I mean, we may offer some collaborative certificates or degree diplomas, but nothing concrete yet. All right. So the next question is from Alok, and he mentions that what is the expected hourly workload per week? I mean, anything specific you want to mention on this? I mean, Sanjay?
So I would not maybe so I would not diplomatically answer this question. So to be very frank, machine learning as such, it requires you to devote time, right? But we have designed the course in such a way. All I can say is that we have created a very interactive material, as well as very interesting material for you. So not only that you would be studying the concepts, but you would be doing some use cases, direct application use cases. So that to my mind would let you struggle less on the application, as well as linking linking the concepts to the application, right? Because you would have sooner maybe faster time to reach to how that particular concept or technique is applied to a real use case, right? Rather than figuring it out on all on yourself, right? So that's the case of we are enabling journey, plus we are designing some of the other additional material, which is showing you through visual appeal, how to read the outputs, and how to maybe explain the outputs, and how to interpret the results, and maybe so how to do storytelling, essentially the creative side of it, right? But definitely, if to pinpointedly answer your question, it would require at least, to my mind, if I would be you, I would at least expect that weekly 12 to 15 hours including the classroom sessions. The live classroom sessions would need to be persistently followed throughout the 8 months of the course, right? So you should expect at least, I'm saying at least 12 to 15 hours, right, per week, including the live sessions.
Right. So I hope that answers your question, Alok. I mean, if you have any follow-up question, you can ask, and we'll be happy to take up. In the meantime, the next question is from Somadip, and his question is, I see a lot of quant roles require C++ programming as well as a skill along with Python or R. Your views on that?
Yes, that's true. And the reason for that is that most of the quant means specifically the derivative pricing rules. These derivative pricing algorithms or front office pricing algorithms are built in low-level languages like C, C++, Fortran. Due to the kind of magnificent speed they would require to, deliver, right? So low level languages have this advantage of maybe allowing you to do the custom built functionality, as well as very fast at processing, which is being bridged more and more by these new analytics scripting languages like Python, Perl, Julia, right? Which you should not be surprised, the methods and the programs with the techniques within these analytics languages, like any machine learning technique, is built in a low level language only. The only thing you are doing is you are calling a particular method from the library, but which is already built in the low level languages. Hence I would see that in going forward, the world is going in a low code no code direction, right, where these Python and these Julia and Perl and these kind of languages are emerging and becoming more dominant, than the low level languages, which are hard to learn for a non programming background or a non computer scientist. uh, so so uh, so it's not a worry, right? Eventually you will see that people generally write a lot of things on JD, but they will appear in obliques, C++ or C or oblique Python, right? So once you have an advanced level skills on Python, many of these jobs will become open to you.
Yes, yeah, absolutely, absolutely, and then it depends also, like, again, what kind of roles also, Somadip. I mean, if you are looking at like non-developer kind of roles, then again, more often than not, just to add to what Sanjay said, more often than not, Python is good enough. But I mean, if you are looking to become a developer, that is like the core IT developer kind of person, right? So then, of course, again, you are expected to know multiple languages. I mean, the more languages that you know, the better it is, right? But I mean, here we are talking about the general field in context of that. Actually, I mean, Python is almost good enough for most of the profiles. But yeah, if you are looking specifically for developer roles, then multiple languages. Well, I mean, some teams even use Java and other languages as well, right? So they are actually depend on like what other, it varies from team to team as well. So that there for developer roles, I mean, more languages you know, more of, I mean, you can apply to more number of opportunities. There's no doubt about that. Am I correct, right? And Sanjay, and adding that.
Yeah, yeah, definitely, that's the case.
Correct. So yeah, sure, Alok, please feel free to, Alok has mentioned that he'll call us. I mean, please feel free to call us and we'll be happy to discuss in detail. Okay, so Vinod has a follow-up question, and he says that do you have any course just covering functional part or domain knowledge of algorithmic trading, not covering the tools and language? Uh, so Vinod, as of now, the courses that we conduct, the intent is to teach you end-to-end everything about algorithmic trading starting from scratch, right? But when you talk about algo development independently, so there uh, some amount of programming becomes actually essential, right? So there actually you cannot escape. I mean, no, we are not about the tools. We are not like using too many tools here, but yes, as a language, we use Python, and then at least one language you need to know if you really want to understand about algorithmic trading, the entire process, how you code the strategy, how you uh, build an algo, how you execute the strategy, how you backtest, parameterize, and everything, right? But yeah, they are also again something. This is like the part of the plan. I mean, current courses, what we do all involves programming, definitely. I mean, in particular algorithmic trading, if you're talking about. But maybe we would have simplified courses for uh, people who do not have a coding background, maybe using less codes or no codes. Actually, that's part of the plan, but that's something which may come in the near future. But as of now, the courses that we have all involves quite deep programming going into it, right? So I okay. So the follow-up is like, I mean, Vinod says that he is already doing courses in language and ML. So wonderful. If you are already doing it, then again, anyway, like again, you already have a background in Python, I'm assuming. So yeah, I mean, in that case, it should be very simple. The Python part is already taken care of in the basic Python, at least, is taken care of in the other courses that you are doing, and it's more about applying that. But again, if you really want to apply that, then again, I mean, and since you have already built or building a background in Python, then why not utilize it as well? So yeah, I understand. You want to go just for the functional part, but here it's like all merged, right? So the functional and the domain. If you're talking about algorithmic trading, algo is what? Algo is nothing but a computer program at the end of the day, right? So ideally, any algo trading course should teach you the algo building as well. So algo building and development would use some use programming. And again, anyway, you have already built the basic Python background. So that's actually should be utilized. I mean, the no coding or the low coding kind of approach is for people who do not have the background, right? But then there are a lot of limitations as well, at least as of now. So, I mean, that's how it is. But yeah, I mean, going forward, we might have more no coding or less coding based courses as well. So with that, we have actually, I see that we do not have any further questions there. I mean, to the participants, any more questions you want to ask, any more queries you have? If not, then actually, maybe we'll close the session for the day. All right. So if you do not have any further questions, then actually let's conclude for the day. Okay. Venkat, for the fee structure, again, depending on which course are you talking about, we will maybe like discuss one-on-one on the course fees and all. So we will definitely give you a call to discuss about that. Right. So with that, we conclude the session. Thanks once again, everyone, for joining in, taking your time out on a Sunday. And special thanks to Sanjay once again. It was like a really informative and a wonderful session. I hope all the participants also had a good time. They have got a good, idea about the field and like what it takes and the career opportunities. So with that, we'll conclude the session. I mean, as many of you already know, so I mean, as a part of our IIQF Deep Dive with Expert series, we continuously keep conducting webinars on important areas of quant, risk, algorithmic trading, other areas of finance, and algorithmic trading and machine learning and related areas. So keep track of our social media pages, websites, and all, and like we would keep posting the updates. So keep following us, keep tracking us, and we see you in the next webinar. Thank you so much.
Thanks a lot. Thanks, everyone.